Along the mighty Yangtze River in China stands an edifice of unparalleled scale and ambition, the Three Gorges Dam. It is not merely a structure of concrete and steel, but a testament to human ingenuity and a beacon of modern engineering. This colossal project, spanning over 2 decades from conception to full operation, redefines what is possible when a nation mobilizes its resources to harness the power of nature. We journey into the heart of this marvel, exploring the immense complexities, the daring innovations, the staggering financial commitment, and how it came to hold the title of the world's most powerful hydroelectric power plant. For centuries, the Yangtze River, a lifeline for millions, was also a force of devastating floods. The vision for the Three Gorges Dam was born from this dual nature, to control the river's destructive power and transform it into a source of immense benefit. Located in China's Hubei province, the dam was designed with a multifaceted purpose: crucial flood control for downstream regions, generation of vast amounts of hydroelectric power, and significant improvements to navigation along the river. This grand ambition necessitated an engineering solution on an unprecedented scale. The construction of the Three Gorges Dam was a generational undertaking. While debates and planning had simmered for decades, physical construction officially commenced in 1994. The sheer audacity of the project demanded sustained effort over many years. The main dam structure itself, a monumental achievement, reached completion in 2006. However, the full operational capacity, integrating all its advanced power generation systems and auxiliary components, would not be realized until 2012. This extended timeline underscores the complexity and the meticulous planning required for such a colossal endeavor. To fully grasp the engineering marvel that is the Three Gorges Dam, one must consider its staggering dimensions. Stretching an astonishing 2,335 meters in length, this concrete wall spans across the vast expanse of the Yangtze. Its height reaches 185 meters, equivalent to a 60-story skyscraper lying on its side. These figures are not just statistics, they represent an immense challenge in structural integrity, material science, and sheer logistical coordination. Every segment of this massive structure had to withstand the immense pressures of the river, while housing an intricate network of turbines and floodgates. Building a structure of this magnitude required an unimaginable volume of materials. The heart of the Three Gorges Dam is its concrete mass. A staggering 27.2 million cubic meters of concrete were poured into its construction. To put this into perspective, this volume is enough to build hundreds of conventional dams. The logistics of sourcing, transporting, mixing, and precisely pouring such an immense quantity of concrete, often under challenging conditions, demanded highly sophisticated engineering techniques and continuous innovation in construction processes. This alone was one of the project's most formidable challenges. Beyond concrete, steel provided the crucial reinforcement, giving the dam its immense strength and durability. An astounding 463,000 tons of steel were integrated into the Three Gorges Dam structure. To fully comprehend this quantity, consider that this is enough steel to construct 60 Eiffel Towers. The precision required for cutting, shaping, and placing this vast amount of steel within the concrete framework was paramount. This combination of robust materials, meticulously designed and executed, ensures the dam's structural integrity against the immense forces it contains and generates, a true testament to engineering excellence. The sheer scale of the dam's construction wasn't limited to what was built, but also what was moved. The earthworks involved in preparing the site and diverting the river were colossal. A staggering 102.6 million cubic meters of earth and rock were excavated and moved. This monumental task involved massive fleets of heavy machinery and countless hours of labor, fundamentally altering the landscape of the Yangtze River Valley. This earth-moving operation alone represents an engineering feat comparable to the largest mining or canal projects in history, demonstrating the profound physical impact of the dam's creation. Such a monumental undertaking, both in terms of engineering and scale, naturally came with an equally monumental financial investment. The estimated cost of the Three Gorges Dam project reached an astounding $37 billion. This figure represents not just the cost of materials and labor, but also the sophisticated planning, advanced technology, and extensive infrastructure development required to bring this vision to fruition. It stands as one of the most expensive single infrastructure projects ever undertaken globally, reflecting the immense national priority placed upon its successful completion and the benefits it was projected to deliver. At its core, the Three Gorges Dam is a powerhouse, meticulously designed to harness the kinetic energy of the Yangtze River. The true marvel of its engineering lies in its power generation capacity. The dam is equipped with 34 main generators, each a colossal piece of machinery capable of producing 700 megawatts (MW) of electricity. These aren't just large generators, they represent the pinnacle of hydroelectric turbine technology. Furthermore, two smaller generators, each contributing 50 megawatts, augment this impressive lineup, showcasing a sophisticated integration of power generation components. With all its generators running at peak efficiency, the Three Gorges Dam boasts an astonishing total installed capacity of 22,500 megawatts. This incredible figure firmly establishes it as the world's largest and most powerful hydroelectric power plant. Achieving this level of power generation required not only immense physical construction but also advanced hydrological engineering and sophisticated grid integration. It's a testament to the fact that harnessing renewable resources on such a scale can fundamentally alter a nation's energy landscape, providing consistent, clean power to millions across a vast region. The output of the Three Gorges Dam is truly staggering. Annually, it generates over 100 terawatt-hours (TWh) of electricity. To put this in perspective, this single dam produces power equivalent to approximately 15 nuclear power plants combined. This immense, clean energy output significantly reduces China's reliance on fossil fuels, contributing to a more sustainable energy future. The steady supply of electricity fuels economic growth and improves quality of life, demonstrating the direct benefits derived from the colossal investment and engineering effort. The impact of the Three Gorges Dam's power generation resonates across vast swaths of China. Its electricity supply reaches 9 provinces and 2 major cities, including the economic powerhouse of Shanghai. This extensive reach underscores the dam's critical role in China's national energy grid and its contribution to sustained development. Powering homes, industries, and infrastructure over such a wide geographical area is a testament to the dam's strategic importance and the intricate distribution network that complements its immense generating capacity. It literally lights up the lives and aspirations of hundreds of millions. To enable its flood control and power generation capabilities, the Three Gorges Dam impounds a truly colossal body of water, its reservoir. Stretching for an astonishing 600 kilometers in length and up to 1.1 kilometers wide, this man-made lake holds a maximum storage capacity of 39.3 billion cubic meters. Creating such an immense reservoir fundamentally reshaped the Yangtze River Valley, transforming landscapes that had existed for millennia. This vast expanse of water is a critical component of the dam's operation, allowing precise control over river flow and providing the necessary head for the turbines. The scale of the Three Gorges Dam brought with it profound human costs, most significantly the displacement of communities. Over 1.3 million people were forced to relocate from their homes to make way for the sprawling reservoir. Entire towns, villages, and farmlands were submerged, erasing centuries of established livelihoods and cultural heritage. This mass relocation represented an unprecedented social engineering challenge, requiring extensive planning and resources to resettle populations, often into unfamiliar environments, a stark reminder of the sacrifices demanded by such large-scale development projects. Beyond individual homes, the rising waters of the Three Gorges Dam reservoir also led to the irreversible loss of invaluable cultural heritage. Thousands of historical sites, ancient temples, traditional villages, and archaeological treasures, many dating back millennia, were submerged. Despite extensive efforts to salvage and relocate some artifacts, countless others were lost forever beneath the waves. This cultural sacrifice represents a significant, often lamented, consequence of the dam's construction, highlighting the tension between progress and preservation on a national scale, a profound impact on China's historical memory. The environmental impact of the Three Gorges Dam is as vast and complex as the dam itself. The creation of the massive reservoir led to widespread habitat destruction, fundamentally altering the ecology of the Yangtze River. This resulted in a significant loss of biodiversity, most notably contributing to the presumed extinction of the iconic Chinese river dolphin, an irreplaceable species. The changing water flows and conditions impacted numerous other endemic species, from fish to migratory birds, transforming the delicate balance of an ecosystem that had evolved over millions of years. The dam's presence also profoundly affects the river's natural processes, with consequences extending far downstream. Silt accumulation behind the dam is a persistent concern, as the reservoir traps sediments that would naturally replenish fertile lands downstream. This reduction in silt impacts agricultural areas and the natural erosion/deposition cycles of the lower Yangtze. Furthermore, the altered water flow and temperature regimes can affect downstream ecosystems, impacting fisheries and aquatic life that depend on specific river conditions. The interconnectedness of a river system means changes upstream ripple throughout its entire length. Another layer of environmental concern involves the dam's potential geological impacts. The immense weight of the reservoir's water and the changes in pressure on the underlying geology have raised concerns about increased earthquake risk in the region. Additionally, the fluctuating water levels can trigger landslides along the steep banks of the reservoir, posing risks to communities and infrastructure. While engineers have implemented measures to mitigate these risks, the sheer scale of the dam means that its interaction with the natural geology of the area remains a complex and closely monitored aspect of its ongoing legacy. The Three Gorges Dam stands as a monument to human ambition and engineering prowess. It epitomizes the capacity to reshape landscapes and harness immense natural forces for development. Yet, its story is also one of profound trade-offs and enduring debate. The sheer complexity of its construction, the staggering financial investment, and its status as the world's most powerful hydroelectric power plant are undeniable triumphs. However, these achievements are inextricably linked to the significant environmental and social costs, forcing a continuous re-evaluation of its comprehensive legacy and the true price of progress. As the world continues to grapple with energy demands and climate change, the Three Gorges Dam remains a potent symbol. It stands as a testament to what is achievable through sheer will and sophisticated engineering, having realized its core mission of flood control and providing an unprecedented source of clean power. Its towering presence on the Yangtze River is a permanent mark on the landscape, an enduring giant that powers a nation. Its story is a complex tapestry of innovation, investment, and impact, inviting continuous reflection on the balance between human ambition and the natural world.